Hello, my name is Tony. I'm live from IDC Learning Center YouTube channel. For today's video, we'll be looking at chemistry JAMB past questions and answers that will help you prepare for your upcoming JAMB examination 2022. So let's get started. For today, question number 1, it says elements in the same period in the periodic table have the same A. Number of shells, B. Atomic number, C. Chemical properties, D. Physical properties. The right answer to that is number of shell, which is option A. Number of shells. Because the element in the same period in the periodic table has the same number of shells but different number of valence electrons. So the number of shells is the right answer for question number 1. Okay, let's move further. Question number 2. Permanent hardness of water can be removed by A. Filtration, B. Adding slaked lime, C. Adding caustic soda, D. Boiling. The right answer to this question is option C. Adding caustic soda. Permanent hardness is removed by all soluble compound of sodium, which will form insoluble precipitate with calcium and magnesium ion present in a permanently hard water. So the right answer is caustic soda. Okay, we move further. Question number 3. It says, calculate the solubility in mole per dm cube of 40 grams of copper 2 tetraoxosulphate 6 dissolved in 100 grams of water at 120 degrees C. The relative atomic masses of copper has been given to us, that of sulfur has been given to us, and that of oxygen has been given to us. To solve for this, we'll first of all calculate the molar mass of copper 2 tetraoxosulphate 6, which is CuXO4. So copper has been given to us to be 64 plus sulfur 32 plus oxygen is 16 times 4. So we add them together. 64 plus 32 will give us 96 plus 16 times 4 will give us 64, which will sum up to give us 160 grams. So now moving further, we are asked to calculate the solubility. So some formula for solubility is mass of solute over molar mass times 1000 times 1000. Okay, so the question says that this copper 2 tetraoxosulphate 6 was dissolved in 100 grams of water. So in this case, when solving, we include this over 1, we include the 100 grams of water underneath the 1000. So we input the value. Mass of solute is given to us in the question as 40 grams. So we say mass of solute is 40 over molar mass is 160 times 1000 over the 100 given to us already in the question, which is over 100. which is 100. So we'll cancel out the zeros. 0 cancel this 0, this 0 cancel this 0, this 0 here cancel this 0. At the end of the day, we have 4 times 10, which will give us 40 over 16 times 1 will give us 16. So we'll break them to the lowest possible value, which is 2 in 20. We give 2 in 40 will give us 20. 2 in 16 will give us 8. So we'll continue. 2 here will give us 10. 2 here will give us 4. 2 here will give us 5. And 2 here will give us 2. So we cannot divide further. So we have 5 over 2. 5 divided by 2 will give us 2.5. So in our option, we go to our option. The right answer for this is option B, 2.50. So the next question is question number 4. It says carbon 2 oxide is considered dangerous if inhaled, mainly because it can cause injury to the nervous system, B, competes with oxygen in the blood, and C, competes with carbon 4 oxide in the blood, D, can cause lungs cancer. So the right answer to this is B, compete with oxygen in the blood. Carbon 2 oxide is a very strong reducing agent and a poisonous gas which reduces the concentration of oxygen in the blood of a human. So it is dangerous when inhaled, so it competes with the oxygen in the blood. So the right answer is B. Question number 5. It says, calculate the volume of 0.5 mole per dm cube of H2SO4 that is neutralized by 25 cm cube of 0.1 mole dm cube of sodium hydroxide. This is a neutralization of an acid with a base. So to solve for this, first of all, we'll write down an equation for this. Of course, when a base neutralizes an acid, it forms salt and water. So we write the formula H2SO4 plus NaOH. So our product would be, okay, let me clean this for sake of space. So it will form Na2SO4 plus 2H2O. So to balance the equation further, we say 2. Yeah, so we have a balanced equation now. So to solve further, we are going to use the formula CAVA over CBVB, which is equals to NA over NB. So our CA stands for concentration of acid, VA stands for volume of acid, and CB stands for concentration of base, and VB stands for volume of base. Our NA is number of acid, NB is number of base. So from the question, they said we should calculate the volume. So the unknown we are looking for is the volume, which is the what? VA. So we make the VA the subject of the formula, but before then, note we cross multiply. So we make VA subject of the formula, which is VA equals to, of course, we'll put the complete values up above. So we say CB VB NA over CA NB. So having done that, we will put the value, the concentration of base. So what is the concentration of base? Here is 0.1. So we say 0.1 times volume of base. The volume in cm cube is 25 times the number of acid. So from the question, this is the acid, the number of acid, there is no value here. So the number of acid is 1. Okay, so over concentration of acid, what is the concentration of acid given to us? The concentration of acid is 0.5. So we'll put 0.5 times, so number of base, so this is our base, sodium hydroxide, so the value here is 2. So we'll put times 2. So when we sort them, multiply them out, we have 2.5 cm cube. So our answer is B. So question number 5 is 2.5 cm cube. So let's move on to question number 6. Question number 6. It says the color of methyl orange in alkaline medium is A, yellow, B, pink, C, orange, D, red. The right answer to this is A, yellow. Methyl orange is an indicator that dissolve in an alkaline solution to form yellow coloration. Yes. Question number 7. It says, what quantity of aluminum is deposited when a current of 10 ampere is passed through a solution of an aluminum salt for 1930 seconds? So aluminum, the relative atomic mass of aluminum given to us in the question is 27. The Faraday constant is 96,500 coulomb. So to solve this we'll be using Faraday's first law of electrolysis. So the formula for Faraday's first law of electrolysis is Q equals to IT. Q equals to IT, where the Q stands for quantity of electricity in coulomb, I stands for ampere, and T stands for time. So to find our quantity of electricity, we say I is ampere, which is 10 times the time given to us in the question is 1930 seconds. So we say 1930 seconds. So our answer will be 19300 coulomb, which is C. Okay, so we write equation for the question, which will give us, since we are looking for aluminum, so we say aluminum, which is Al 3 plus, so gain 3 electrons, so we have Al as aluminum. So aluminum, therefore our aluminum deposited 3 Faradays of deposited 27 grams of aluminium. So having done that, we say the three Faraday of aluminum, our Faraday, which is F, is 96,500. So our answer will be 289,500. So to get the value for our 19,300 column, we say how many will it deposit. So we say 19,300 will deposit 27 over 289,500 times 19,300 over 1. So our answer will give us, first of all, we'll cancel out these zeros. So when you multiply them out, we arrive at 1.8 gram. So the answer to this question is option B, 1.8 gram. So question number 8. It says, which of the following equimolar solution will have the highest pH? So the answer to this question is sodium hydroxide, which is B. The reason being that sodium hydroxide is a strong base. Therefore, it has the highest pH among the options given to us. So the answer is sodium hydroxide, B. Question number 9. It says, a hydrocarbon X with a molar mass of 26 consists of 92.3% carbon. What is its molecular formula? So to solve this, we are going to draw a table. So let's draw our table. Our table, we split the board. So we're going to draw a table. So we draw a table into, we are given hydrocarbon, so which is to find hydrogen and carbon. So we draw a table into, so we split them. So here will be for C, which is carbon. Here will be for hydrogen. So this is the space for our hydrocarbon. So hydrocarbon, so first of all, we look for the percentage composition. What is the percentage composition? So the percentage composition for carbon given to us in the question is 92.3. So that of hydrogen is not given, so we have to look for it. So how do we look for it? We subtract 92.3 from 100, which will give us 7.7. 7.7. So the mole ratio, we are going to look for the mole ratio. The mole ratio, before we get the mole ratio, we are going to what the relative molecular mass of carbon in the question. The relative molecular mass of carbon relative atomic mass of carbon is 12, hydrogen is 1. So we are going to find the mole ratio by dividing the percentage composition with the relative atomic mass. So the mole ratio will be 92.3 over 12 divided by 12, and this one is 77.7 over 1. So at the end of the day, our answer will be 7.7. Then this one still remains 7.7. So we are going to divide by the smallest. Divide by the smallest. So the smallest, since they are the same, we divide by the same 7.7, which will give us 1. So 7.7, which we divide by 7.7, will still give us 1. So therefore, the empirical formula, we are meant to get the empirical formula before we get the molecular formula. So the empirical formula is equals to C. So the value at the end of it, is 1 under carbon. So it means C. While the value under hydrogen is 1, so it becomes CH. So the empirical formula is CH. So we'll solve further for molecular formula. So molecular formula will be CH close bracket N. N means the unknown. So we are going to look for the N. Okay. So the question says the molar mass has been given to us, which is what? 26. So we'll say 26 equals to CH. To get our CH in the bracket, so we'll say 12 plus 1 close bracket N. So therefore, okay, we solve further. We say 26 equals to 13 close bracket N. So making N the subject of the formula, we say N equals to 26 over 13. So which will give us 13 here 1, 13 here will give us 2. So our N is 2. So we say CH close bracket, our N is now what? 2. So which is, this 2 is a multiplier of everything inside the bracket, the CH. So C, which is 1, which is to give us C2. The H is also 1 times 2 will give you H2. So our molecular formula is equals to C2H2. So the answer to this question is A, C2H2 is our molecular formula. Okay, we are moving to the next question, which is question number 10. It says, which of the following method can be used to obtain pure water from a mixture of sand, water, and methanoic acid? Okay, they gave us neutralization with sodium hydroxide followed by filtration. B, neutralization with sodium hydroxide followed by distillation. C, fractional distillation. And D, filtration followed by distillation. So the right answer to this question is D. D, filtration followed by distillation. Because sand is a solute substance which is insoluble both in water and methanoic. So therefore, it can be separated by distillation. So the answer is filtration followed by distillation. So question number 11. Calculate the number of moles of HCl present in 20 cm³ of a 0.75 mole solution of the acid. So to solve for this question, we're going to calculate, we're asked to calculate the number of moles. So the formula for number of mole is number of mole equals to V, which is volume, times concentration over 1000. So the volume in the question is 20 cm³, which is 20 times the concentration in mole is 0.75 over 1000. 1000. Okay, let me put the 1 over 1000. So when you multiply them out, our answer will give us 1.016 mole. Or approximately 0.015. Okay, so from the option we have 0.015. So A is the answer. A, 0.015 mole. Okay, question number 12. It says a metal X form 2 bromides with the formula XBr2 and XBr3. Okay, what type of bond exists between X and bromine in the bromide? So looking at it, like the question states, a metal, so the X here is a metal. So they're asking us what type of bond exists. And of course, we know that the bromides, the two bromides, are non-metals. So reaction between a metal or a bond between a metal and a non-metal is usually classified as ionic bond, which is also known as electrovalent bond. So ionic bond is the rightful answer because it is a transfer of electrons from a metallic atom to a non-metallic atom to form ionic bond or electrovalent bond. Okay, let's go to the next question. Question number 13. Question number 13. It says when temporary hard water is boiled for some time in a kettle, the inner surface of the kettle becomes coated with a deposit of A. Calcium tetraoxosulphate 6, B. Calcium triosocarbonate, C. Calcium hydrogen triosocarbonate, and D. Aluminum triosocarbonate. Of course, the answer to this question is calcium triosocarbonate, B. Calcium triosocarbonate 4. Calcium triosocarbonate 4, because layers formed by gradual decomposition of calcium hydrogen triosocarbonate 4, calcium hydrogen triosocarbonate 4 to calcium triosocarbonate 4, which is the one deposited on the inner surface of your kettle. So the answer is calcium triosocarbonate 4. Okay? Question number 14. Question number 14, it says, what weight of sodium chloride is needed to make 2.0 dm cube of a 1.5 mole solution? To solve for this, we will first of all look for the molar mass of sodium chloride. So molar mass of sodium chloride, molar mass of sodium chloride will give us 23 plus 35.5, which will sum up to give us 58.5 grams. So 1.0 mole solution of sodium chloride contains 58.5 grams in 1.0 dm cube solution. So to solve for that, we say 58.5 over 1.0 times the 1.5 given to us over 1. So when we solve out for that one, we have 87.75 grams. So therefore, to solve for 2.0 dm cube, we say the value gotten there, we say 2 times 87.75 grams, which will give us 175.5 grams of sodium chloride. So our answer in the option is B. Option B, 175 grams. So the next question is question number 15. It says, in the Haber process for the manufacture of ammonia, the catalyst commonly used is finely divided A. Vanadium, B. Platinum, C. Iron, D. Copper. So the answer to this is C, option C, which is iron. Iron is the catalyst which is commonly used in the process, in Haber process for the manufacture of ammonia. question number 16. Question number 16. It says, which of the following is formed when maltose react with concentrated tetraoxosulphate 6 acid? A. Carbon 4 oxide, B. coal tar, C. charcoal, D. toxic fumes. Of course, we know that maltose is a sugar produced by a breakdown of starch. So it is a disaccharide. So when concentrated tetraoxosulphate 6 is added to a sugar, it forms what we call charcoal. So the answer to option C, to question 16 is C, charcoal. Let's move on to the next question, question number 17. Question number 17. It says, which of the following compound is a normal salt? Which of the following compound is a normal salt? Which of the following compound is a normal salt? Of course, looking at the compounds given to us, we have all of option A having H, option B having H, option C having H. So the answer, which indicates the presence of acid. So the right answer to this question 17 is D. D, because a normal salt is formed by a complete replacement of the replaceable hydrogen atom of an acid molecule by means of a metal or a group of elements acting like a metal. So the option is sodium triisobicarbonate, which is option D. The next question is question number 18. It says, which of the following statements is correct about the periodic table? A. Elements in the same group have the same number of electron share. B. The non-metallic property of the element tends to decrease across each period. C. Elements in the same period have the same number of valence electrons. D. The valence electron of the element increase progressively across the period. So the right answer to this question is option D. The valence electron of the element increase progressively across the period. As the elements move across the period on the periodic table, there's an increase in the electron from one element to the next element in the same shell. So the right option is D. Question 19. It says, in the diagram above, X is the A. Enthalpy, B. Activation and activated complex, C. Activation energy, D. Enthalpy change. Now this is the X given to us. This is the X we are asked to identify. So here is the reactant, here is the product. So the right answer for this is D, option D, enthalpy change. Enthalpy change, because it is the difference between the energy and the product. Energy and the product, and the energy of the reactant. Between the energy and the product and the energy of the reactant. Finally, for today, question number 20. It says 200 cm cube of a gas at 20 degrees C exert a pressure of 700 millimeter mercury. Calculate its pressure if its volume increases 350 cm cube at 75 degrees Celsius. To solve for this, we are going to look at the question critically. We are given 200 cm cube, which stands for volume. 25 degrees C, which stands for temperature, and 700 millimeter mercury, which stands for pressure. Also, we also have another one here, our volume 350 cm cube, and we also have another one here, our temperature. So this is general gas law question. So we'll be solving it using the general gas law equation. So rule for, so our general gas law equation using general gas law. So the formula for general gas law is P1 V1 over T1 is equals to P2 V2 all over T2. So our P1 from the question, P1, the first pressure here is 700 millimeter mercury. Our V1 from the question, the first volume in the question is 200 centimeter cube. Our T1 is 25 degrees C. So we are going to convert it from Celsius to Kelvin. So in order to convert to Celsius to Kelvin, we're going to add it with 273, so which will give us 298 Kelvin. So we'll move on to the next one, which is P2. So P2 is not, there's no other pressure here in the question, so our P2 is the unknown value. Of course, they say we should calculate the pressure. So the next one is our V2. Our V2, this is the next volume in the question, which is 350 cm cube. So the next one is our T2. T2 is given to us to be 75. So we'll convert it, 75 degrees Celsius, we'll convert it to Kelvin. So by adding 273, which is sum up to be 348 Kelvin. So we'll go back to our formula, which is P1 V1 over T1 equals to P2 V2 over T2. So the unknown we are looking for, P2. So we'll make it the subject of the formula. Still remember to cross multiply because of the equality sign. So we'll break it down, making P2 the subject of the formula. P2 equals to P1 V1 T2 over T1 V2. So we'll start inputting the values. So which is our P1 is 700 millimeter mercury, which is this. Our V1 is 200, so we are going to multiply by 200 cm cube. Then our T2 is 348 Kelvin. 348 Kelvin over, so So what is our T1? Our T1 in the question is 298. 298 Kelvin times our V2. What is our V2 here? Our V2 is 350 cm cube. 350 cm cube. So we'll cancel out cm cube, cancel cm cube. Kelvin cancel this other Kelvin here. So our unit, the unit for answer will be millimeter mercury. So when you multiply them out, you say 4872000 over 104300. So our final answer would be 467.11 millimeter mercury. So the right answer for the question is C, 467.11 millimeter mercury. So this marks the end for today's class. Thanks for watching, and I hope you enjoy this video. Please subscribe to IDC Learning Center YouTube channel if you have not done so, and also share and drop a nice comment for me to see. Bye for now, till I see you again.